So a student of mine had some questions about iGCSE paper 4. In the description are two links. One is to this Jamboard, which you can also get by scanning the QR code there. And the other link is to Geogebra, which I use in some of the other questions. So, first thing I would do is, using the space in the rectangle, write down the perimeter, should I say the area of the two rectangles. Okay, so that's going to be x minus 1 times 2x plus 3. And this one is going to be x plus 1, x minus 2. And I need to expand those. So that's going to give me 2x squared plus 3x. I'm going to leave that for the time being because it's also going to give me minus 2x. So I'm just going to combine them straight away to give me x. And then minus 1 and positive 3 gives me minus 3. Okay, and this one here, x times x gives me x squared. That's going to give me minus 2x. And that's going to give me 1x, so overall it's going to be minus x. And then plus 1 times minus 2 gives me minus 2. So all I need to show is that this area, the one on the left, take away the other area is equal to 62. Now, it's important I have brackets in this because when I remove the second brackets, it's going to change some of the signs. Or I can just do it without doing that, okay? But I'm just going to remove the brackets in the second one. So 2x squared plus x minus 3. Okay. And so I'm taking away x squared, so that's still going to be taken away. The next one, I'm taking away minus x, so that's actually going to be plus x. And then the next one, I'm taking away minus 2, which is going to be plus 2, and that is equal to 62. Collect my like terms here. So we've got 2x squared minus x squared. Okay, so I combine those together, that gives me x squared. I've got x, which is positive, another x, which is positive, gives me 2x. I've got minus 3 and plus 2, which is going to give me minus 1. That is equal to 62. I want to make the right-hand side equal to 0. So you can see I'm going to have to take away 62 from both sides. That's not going to affect x squared. It's not going to affect 2x. Minus 1 minus 62 gives me minus 63. And that's now equal to 0. I've got back to where they started. It's always worth, when it's a show that question, to show a little bit more. Okay, so this is an expression. At the minute it's not an equation. But I just need two numbers which multiply to make minus 63 and add to make 2. Now I'm just going to think of factors of 63. Well, I can only think of two of those which have a difference of 2, so it's 7 and 9. 7 times 9 is 63, minus 7 times positive 9 is minus 63, positive 7 times minus 9 is also minus 63, so which way do I have to add them to make plus 2x? Well, that's going to have to be negative, and that's going to have to be positive. This links in nicely with the second part, so we've already factorized it. So the only difference between this part and the next part, the previous part, is this is an equation. So either x equals minus 7 or positive 9. But that's not what it's asking you. It's asking to find the difference between the perimeters of the two rectangles. Okay, so for that, I'm going to go back and look at the rectangles and substitute the two values in. Okay, so the first rectangle if I substitute those values in, I put 7 in, sorry, minus 7 in. Now if I put minus 7 in, it's going to give me a value. Sorry, let me start again. Minus 7 plus 9. I made a mistake here. I've switched these rounds. Apologies about that. So minus 7. And that is plus 9. And what that means is the solution is going to be the way around. So that one's going to be 7. It's going to be minus 9. Now, if I substitute minus 9 into one of those, I'm going to get a value of a length which is negative. Okay, so I can't have that as a solution. So the solution is x equals 7, but I still don't have the difference between the perimeters. And to do that, I'm just going to substitute 7 into these. But remember, we're finding the perimeter here, not the area. So 7 minus 1, that's going to give me 6. 2 times 7, 14, plus 3 is 17. Okay, 7 plus 1 is 8, and that one is 6. So I've got a rectangle, that's obviously 6, that's obviously 17 as well, and that's obviously 8, obviously 6. So I just want to know the difference between those. So I need to do 2 times 17 plus 2 times 6 I'll give me the perimeter of 1, and then I've got 2 times 6 plus 2 times 8. That will give me the perimeter of the other one. Okay, I encourage you to use a calculator to do this. There's no need to try and do this in your head and make a mistake. So that perimeter is 46, and this one is 28. 46 minus 28. 18. Okay, that's your answer. So this is the student's work. They submitted it to me for me to check, and all you have to do here is substitute minus 3 into your function, 0 into your function, and 1 in. These ones here are actually all correct. Now, the issue with this question and their answer to it is that this value is not where it should be. So that, I believe they plotted 4.1 in error when it should be minus 4.1. So it's going to be somewhere about there. Okay, so this is the correct point of there. And to draw the graph, this is a cubic. I'm going to do my best to connect. I'm going to use a different color here. I just connect all the points with a smooth curve. Okay, so that's part B done. Part C, use your equation, use your graph to solve the equation. Well, we want to know when our function, which is x cubed plus 3x plus 2, crosses the function or intersects the function y equals 0. And the y equals 0 is actually the x-axis. So all I need to do is think about this value here. Whenever we talk about solutions, it's always the x value we're interested in. So x is from there minus 3.2. In an exam, you don't have access to GeoGebra. this QR code will take you to the GeoGebra page of all these questions together. You can see a screenshot of it there, and that's the curve, and that's where it intersects, so minus 3.20. You can write it as coordinates, but as I said, we're interested in the x-axis, so the x-coordinate is minus 3.2. And as you can see from this very accurate screenshot, our previous graph is actually pretty accurate. Okay. Now, we need to compare what we have here to what we've drawn. Now, what we drew, what we had this. Bad idea. We had this. We had x cubed. Okay, we had 3x squared. And we had plus 2. So instead of drawing this function, I can just manipulate it to make it what I want. So I want to know, how do I get rid of plus 2x? Well, I'm minus 2x. So then that gives me x cubed plus 3x squared plus 2 is equal to minus 2x. So I've already got this function drawn. And if I just plot this function, y equals minus 2x, we're interested in the x-axis where they intersect. Now you can tell that because it says a suitable straight line, and y equals minus 2x is a straight line. So if I go back to here, so what I'm going to do here in a different color, I'm going to draw y equals minus 2x. Okay, now to draw a straight line I just need 2 points. I always pick x is 0 as 1. Okay, so that's obviously going to go through there. And maybe I'll pick x is equal to 1 when x is equal to 1. This is going to be minus 2. Got to be careful with the scale here because they're not quite the same. That's 2.5, so that's there. Now, I struggle to draw a straight line, but on the next slide you'll see that I have this on GeoGebra. And this point here, the x-coordinate of this, is the answer we're interested in. So as you can see from a far more accurate drawing here, it's minus 2.52. You would be allowed a bit of tolerance. So minus 2.5 would be fine. Okay, there it is again. That's y is equal to minus 2x. And this is our original function, the cubic, which was mentioned at the start of this question. So this one here, so we've got a line which all we know is y equals k, and that k must be an integer. Now if it has 3 solutions, that means there's 3 intersections. Now in an exam, what you would do, you've got your function here, and you would take a ruler and you'd trace your ruler across until it intersects the line 3 times. Now there would be an infinite amount of solutions, but we're told that k is an integer. So if I go straight to my GeoGebra, it makes much more sense. So I started at the top and I drew the line y equals 7. Well, that's red because that doesn't, it has 1 intersection, but we need 3. Okay, so y equals 7, so k can't be equal to 7, doesn't work. And obviously the next one down, if I go up, it's not going to have any more. The next one down, I chose y equals 6. Well, that's got intersect a and b, that's only got 2, so it can't be that. And then I go down one more, I draw the line y equals 5. You don't have to draw this line, you could just trace it across with your ruler, and you can see the solutions C, D and E, the intersections with those 2 lines. So it could be 5, okay. I go down again, it could also be 4. It could be that point F, G and H, as in there 3 intersections. 3 intersects. It could also be 3, I, J or K. Now when it drops down to 2, you can see it only intersects twice, so it can't be 2. And if you keep going down, y equals 1, it only has one solution. If I did y equals 0, we've already done that one, it only has one solution. So you've got a choice of answers here. And you have, this is very important that it's an integer, so you could write down 3 or 4 or 5. Don't put multiple answers in case one of them is wrong for whatever reason, you lose all your marks. And that's it.